We don't have to be perfect with this stuff. You just have to have a general idea of what's the word that you heard. Okay. All right. So first rule of graphs is to know what graph you're looking at. We have an original function here. We have a first derivative here. And we have the second derivative here. So when looking at these graphs, this gives you your x comma f of x. And this is trying to think of the right wording without making it confusing. Well, let's move on to this one for a minute. So this will tell us increasing and decreasing and potential max and mins. This will tell us concave up, concave down, and points of inflection. So what happens is this information, be it whatever graph, whatever graph we're on, we have a function that's going to tell us what is going on. And with this function, because it's all above the x-axis, all that's above the x-axis, we know that the first original graph is always increasing, okay? And we can see that through all of the slopes of the tangents. They are all increasing no matter where we go on this graph. They're always increasing. They're never decreasing, okay? Now, if we do that same thing to the second derivative, we will see that these tangents are going down until they hit 0, and then they start going up. So wouldn't it make sense that all of this graph and all of these values are below the x-axis because all of these are negative slopes? And then we hit 0, and there's a 0 slope right here. And then we start increasing. And all of these slopes are positive. So even though we're on a different graph, it can still give us explanations about the second derivative and about the original function. So you can kind of see information on both sides of the graphs, whether we look at the middle one, the first derivative, and we can go back to the original, or we can go to the second derivative. Or if we are like on the original function, we can go to the first derivative. I guess the first derivative is the only one that can tell us stuff on both sides. The second derivative could tell us information about the first derivative. Because we know it goes through the 0, there's a critical point or it crosses somewhere, and the slope of, or where this is at 0. That's a significant point of change. And really what we see is increasing. There's a change in concavity here, and then it just continues to increase. And the reason we talk about x cubed, I think, is because you get 3 different versions of the graph, but tell us so much. Like all of this is concave down. All of this is concave up because it's above the x-axis. It crosses here, so this is a point of inflection. All of this is above the x-axis, so that means it's the original function, f of x, is increasing. But the slopes of the tangents are all negative, so that means this second derivative, it's below the x-axis. So there's a lot of information to pick apart and just analyze and figure out what we're looking at and what we're looking for. Which actually brings us to question number 3 in the AP exam. It was the figure of f prime, the derivative of the function f. So the figure above shows the graph of f prime. So we know this is f prime. You have to keep that in mind. F prime. I better write it because that doesn't look like f prime of x. What graph are we looking at? So this is going to tell us increasing and decreasing, and this is going to tell us potential max and mins. Okay? So how I focus my energy is I notice all of this is above the x-axis. So I put a plus sign there. And I know, oh, don't freeze. There we go. Oh, don't freeze. All of this is negative. And then we keep going, and then all of that is negative. And then it swaps over to being positive. Okay, so all of this is increasing. And if we go increasing to decreasing, that's going to be a potential max. And if we go decreasing to increasing, that's a potential min. And then this is a no slope, still decreasing, and then zeroes out, and then starts increasing again. But this is still positive to positive because everything's still above the x-axis. So this is potentially telling us what the original graph is doing. Well, that's not our focus for this question. And we're like, well, then why'd you do it? Well, because that's what's the original graph is what's happening on the original graph. It says the graph f prime has horizontal lines at x equals -3. So the horizontal line there. X equals 2. There's a horizontal line there. And then 5. There's one there. And then there's a vertical line here at 3. Okay? Find all the values of x where the second derivative is less than 0. So that means our slope has to be decreasing. So when we look at these, is this decreasing, decreasing, decreasing? So from -7 all the way to -3. And then we have all of this is increasing until we get to 2. Then we have 2 to 3. And then we have 3 to 5. Can we include 3? If we could include 3, we could put a bracket there. Can we include 3? And when we look at this, it says that there's a vertical tangent at x equals 3. So if it's vertical, it's a vertical tangent, that means that it is some number over 0, which is undefined. Because we can go up or down, and then we don't go right or left any. So this cannot be included because it's not positive or negative. It's nothing. It's not possible. So when I look at my intervals, those are my intervals that I'm focused on. Like these are going to be decreasing tangents. These are going to be decreasing tangents. These are going to be decreasing tangents. Everything else is increasing. So if I were to answer this, find all the values of x for which I don't see what's wrong with this. I honestly think this is what we would get. So let's test it out. Question number 3. What do they tell us? From -7 to 3, 2 to 3, and then 3 to 5. 1 point is earned from -7 to 3. 1 point is earned from 2 to 3, 3 to 5. Yeah, I feel like that's what I have on my paper, so I would consider that good luck. You can obviously see they say f double prime exists and f prime is decreasing on all intervals. So you could add that in if you like, but I'm kind of fine with my answer. I don't see a problem with it. On to the next one. Oh, shoot, I don't have the chat up. Let me check the chat real quick. Okay, good. Recent events. Everything looks kosher. Okay. I just keep checking the questions tab. I was just seeing if okay. So the temperature in degrees Celsius of an oven being heated is modeled by an increasing differential function h of time, where t is measured in minutes. The table above gives the temperature as recorded every 4 minutes over a 16-minute period. Write an integral expression in terms of h for the average temperature of the oven between the time t of 0 and t of 16. So an integral expression. So when I hear that, I'm looking for an integral from 0 to 16 of h of t dt. Right, an integral expression in terms of h for the average temperature. So the average temperature, we need to do this. We need to divide it by 16. And you're going to go, whoa. Why are we doing that? Well, when we think about this, remember the average rate of change, f of b minus f of a over b minus a. The integral legit does this for us. That's what the integral does. What we are missing is the bottom piece, the b minus a part. Well, if I do b minus a, what is 16 take away 0? 16. So the integration piece gets us the top. The 1 over 16 gets us the b minus a. Because if I do 16 take away 0, I just get 16. But it's in the denominator, so that's why it's 1 over 16. So that would be the average temperature between the times 0 and 16. And you're like, well, that's pretty far-fetched, Mr. Schmidt. But remember, you're in the basic understanding of integrals. And we'll get there. I promise you we'll get there. But for right now, just understand like you don't know everything you need to know about integrals. The reason this is in here, obviously, is because the second part of the question tells us to use a left Riemann sum. But adding this piece into it, if you were already seeing this, when you actually get there, this will make more sense. But it won't be the first time you saw it, even if you've never been taught it before. So I'm just trying to make sure you see other things even before you know what they are, because you do know the second half of this question. It says, estimate the average temperature of the oven using a left Riemann sum with 4 subintervals of equal length. Show the computations that lead to your answer. So we know if we're doing a left Riemann sum and we're starting at 0, that even though we go to 16, that's not important. We start on the left-hand side. 0 goes up to 65. And then 4 goes up to 68. And then 8 goes up to 72. And then 12 goes up to 80. And none of these need to be drawn to scale. That's not our goal either. Our goal is we want to find the areas of each one of these. We'll call it area 1, area 2, area 3, and area 4. So for area 1, we're going to do, actually, I've been using in class and I really like it. I'm going to do height times the width. If I want to find the area of a rectangle with base times height, length times width, whatever you want to call it, I'm going to do height times width. Because my height is 65 times my width, which is 4. Then I'm going to go to A2. A2 is height times width. Height of this one is 68. The width is still going to be 8 take away 4, it's still going to be 4. A3, so A3 is 72, oh, height times width, sorry. 72 times 4. And then area 4 is right here. We're going to do height times width, which is 80 times 4. Take those 4 values, add them together, and average temperature of the oven using a electric remote. Find the average temperature. So this would be the total temps overall. Then we want to divide it by 16. So we're going to take this solution after we add them all together, and we're going to divide by 16 to get the I have no idea. I'm just mental mathing it quickly. 20, 23, 2, 4, 6, 8, 10, 11, 1130. Then we're going to divide 1130 by 16. Calendar. 1130 divided by 16, 70.625. 70.625. This is the average temp using a left Riemann over the interval x equals 0 to 16. Or we could do 0 less than x less than 16. However you want to do that interval. Although I think I would have to do this beast. I don't know. How did they write their interval? Let's take a look. Wrong question. Okay, so here we are. Ooh, 1 over 16, 0 to 16, h of t dt. Ooh, hoo, hoo, hoo. 65, 68, 73, 70. Oh, they times it by 4 divided by 71.5. Is that what I got? Must have did my math wrong. Bummer. And all they did was say average temperature. Huh. Didn't leave a whole lot to question there. Where did my mental math go wrong? 12, 20, 22. Oh, 22. Why did I put 23 there then? This is 22. I got it right now off the rip. Now, what's 1120 divided by 16? 70. Ah, whatever. Anyways, how about I check my math with my calculator, but don't do the math. Oh my god. 64 times 4. That's way off. Okay. Well, I failed right off the gate. Wait. 65 times 4 is 260. Okay. 68 times 4 is 272. That will make a difference. And 72 times 4, oops, 288. And then 80 times 4, 320. Okay, so then 260 plus 272 plus 288 plus 320 is 1140. Thank you. Divided by 16 equals 71.25, which I still not the solution they got. Interesting. Plus 68 plus 73. 65 plus 68. 286 times by 4 divided by 16. 55, 68, 73. Okay, so I don't know how to write. Awesome. Well, hopefully they would see that mistake, and I would definitely lose points, but hopefully I would only lose like 1 point. So then that would change that number, and that would give us our solution that we're looking for. One, 29. All right. Questions, comments, concerns? No questions. And anything? No questions there. All right. Looks good. Well, you have it. I will post these on YouTube so that you can see them. Sorry for the couple mistakes. They happen. But mistakes and wrong answers are opportunities for growth and learning, understanding what you did wrong. Get rid of that. There we go. All right. Well, without further ado, I'm going to pop off so I can get this posted on YouTube. And that's it. Once again, if you have any questions, join the Discord, put the questions in the questions tab. I will answer them however I can, in the order I can. Just trying to make you successful. So, without further ado, have a blessed day.